Hello, YouTube. So I thought I would start off with differential equations. It was a course that I just took this past spring, and I did not do the best. Well, I don't know. The verdict is still out. I did good on a couple exams, and a couple others I didn't do so hot on. So maybe I passed, maybe I didn't. I think I did pass. Anyway, I'm going to start over from the beginning just to kind of reinforce my knowledge. If it helps you, great. So in differential equations, we have, it's sort of a combination of calculus and algebra. And in many cases, making a differential equation into an algebraic one with, like Laplace transforms and stuff. I'm okay at them. I wouldn't say I'm super good at them. But anyway, I thought I would start at the beginning of differential equations, like what is a differential equation? Well, a differential equation is basically an equation that has a derivative in it, for the most part. I'm sort of learning. I'm still a student. I'm still learning what all of this stuff is. And I thought I would do a couple of examples and kind of show how to do them step by step. So in this particular problem, we have the third derivative of y plus the second derivative of x plus the first derivative plus the actual function is equal to 0. Well, I'm sure there are other possible solutions, but what I'm going to be focusing on this is phi of x equal to sine of x plus cosine of x a solution? And the way that we would check this is we would take the first derivative of phi of x and the second derivative of phi of x and the third derivative of phi of x, and we would plug them in. I also forgot, this is an initial value problem, but I'll move it on to the next screen. So, one moment. Okay, so I included the values, initial values. So phi of 0 is equal to 1, phi prime of 0 is equal to 1, phi double prime of 0 is equal to negative 1, and phi triple prime of 0 is equal to negative 1. So the trick is to just differentiate each time. So sine of x plus cosine of x gives us cosine x minus sine x. And again, minus sine x minus cosine x. And again is sine x minus cosine x. And if we want to verify, if this is true, obviously we can add all these up together. Does it give us 0? Well, sine x plus cosine x, and we have, negative right here, so this and this cancel. Cosine x minus sine x, and we have sine x minus cosine x. All of them cancel. It does satisfy the equation. It does work. And for this purpose, if we wanted to check that one, what we would do is that we would plug in these values of zeros into the function that we're right here. So, for this one, we would plug in sine of 0 minus cosine of 0. Is that equal to negative 1? And it is, because sine of 0 is 0 and cosine of 0 is 1. Negative that is negative 1. So negative 1, and then we have negative 0 minus negative 1. Sorry, right, minus 0 minus 1. Minus 1. So this one is cosine of 0 minus sine of 0, which is just 1. And sine of 0 plus cosine of 0 is 1. 1 plus 1 minus 1 minus 1, 0. So it, satisfies the equation. So for these particular types of problems, you might get like an e to the x, e to the 2x, 7x to the 13th power, something like that. The trick is to just, if you're given like some differential equation and then you're given some function that could be a solution, the trick is to take that function that could be the solution and differentiate it so many times, as many times as you need, as many times as there is a derivative, and plug it into the equation and seeing if it satisfies it. It's really simple at this point. So with that, I'm going to be going on to my next example. So first order differential equations. Sometimes you'll see y prime, which is the same thing as dy dx. And the first thing I'm going to be covering is separable. Dy dx. So what this means is, can we separate the variables? So dy dx is equal to xy minus 10 plus x to the 7th y to the 3rd. Can we separate x and y? No, we can't. Well, we could factor out an x and y, but it wouldn't really do much. For this one, we can. Dy dx is equal to 3x plus xy squared over y minus 7. We can do something like this where we factor out an x times 3 plus y squared over y minus 7 is equal to dy over dx. And we're almost there. So now we have to do a little flip. So we want to multiply by dx over here, and then divide by this, and multiply by this to get it all on that side. And it looks messy, so I'll do it right here. So we have x dx on the right hand side, and we have that equal to dy times y minus 7 over 3 plus y squared. And that's how you separate them. So I want to solve dx over dt is equal to 5x squared t cubed. First step is to separate the variables. Dx over x squared equal to dt. I keep dropping my marker. 5t cubed. And now we just integrate. That gives us 1 over x equal to 5t to the 4th over 4 plus c over 4. And we could just say that it's equal to just c, but I'm going to leave it as c over 4. And now we're solving for x, so we're going to multiply it onto this side. So we have x times 5 t to the 4th plus c over 4 is equal to -1. And we're going to multiply and then divide by this term. So that would give us x is equal to -4, -4 over 5 t to the 4th plus c. Which is what x would be in this case. And that's how you would solve this separable equation. In this problem, we have a y prime is equal to x to the 5th times y plus 1. And we have this condition y of 0 is equal to 4. So, we got to remember that y prime is dy dx equal to x to the 5th y plus 1. And here we just separate the variables. Dy over y plus 1 is equal to dx x to the 5th. And then we just integrate. Just integrate and we get natural log of y plus 1. And this is absolute value. X to the 6th over 6 plus c. And we're solving for y in this instance, so we're going to raise it to the power of e, like that. So that means that this cancels, and we're just left with y plus 1 is equal to e to the x. That's an ugly x. X to the 6 over 6. And because this is a constant, it just kind of goes to the front, c. And we're solving for y, so it's y equals to c e x to the 6 over 6 minus 1. And we have this condition, y of 0 is equal to 4. So y is equal to 4 and the x value is equal to 0. So we have c e to the 0 minus 1. So that gives us c e to the 0 is just 1. 4 plus 1 is 5, so that gives us 5. C is equal to 5. So y is equal to 5 e to the x to the 6th over 6 plus -1. -1. And that just wraps up today's little practice. Just remember, if it says y of 0 is equal to 4, this is the x value, and this is the y value that you're going to be plugging in. And this is just very basic beginning stuff. It'll get more complicated as I go through the textbook again. So thanks for watching. Have a good one. Take care. Bye.